back. How are you? I'm so excited to see everybody. Again, go ahead and give me a hi or hello in my chat. Anything to let me know that you can hear me and you are ready for tonight's light and optics lesson, because we are ready to teach it to you, and we are so excited to see you here again or for the first time. Welcome, welcome. And in fact, you'll see in our agenda here, we always start with a welcome, and that was that. Welcome. Hi. I'm Coach Allie. As most of you know, I'm so excited to see you and work with you today, but I will not be teaching today's lesson. As you know, we're bringing in a different superstar teacher for every single lesson this week. So my teaching days ended on Saturday, but I will be here coaching you all week long, so don't worry, you'll get plenty of me too. But today, we have something super special. After our brief overview of the MCAT, which I'm going to keep pretty brief because we just did it yesterday, but if you want the slides from it, I can email you afterwards. My email is up above. You can go ahead and email me there at consultantteacher@kaplan.com. And no worries, it does go directly to me. It just doesn't sound like it does, but it's because I'm the consulting teacher for Live Online Special Events. So it really does go to me. And shout out in my poll if you've gotten a response email from me. I know some of you are still waiting because we got a little bit backed up yesterday. So if you are still waiting, no worries. I'm getting to you. I know it's there, and I can't wait to work with you. And there is that. So we're going to start with this really brief overview of the MCAT. We know that the MCAT is very, very long, and it's owing to the fact that they ask a lot of questions. But even though they ask us a lot of questions and it's such a long test, time-wise, the time never feels like enough. Am I right? I feel like yesterday we talked a lot. And we had a coaching session earlier this week about timing and how to feel about the timer ticking down there, and how to get over the anxiety and nerves. So if you're still nervous about that, don't be, because you can get over that with practice and building that confidence, right? Because that's like a confidence issue. So we're gonna build it up. Oh, hi, Allie. Oh, you're so welcome, Shirley. I'm trying. There's a lot of us. Scoring for the MCAT, we know goes up to 528, but most of us are shooting for what score? Can you remind me, y'all? What is the average admit score, or score range, if you know the score range? What did we say? What did we say it was? Oh, Ashworry, I love when you talk Harry Potter around me. I wish I did. Listen, if I had a time turner, I can't even tell you. Can't even tell you how much I could get done. And that average admit score is going to be, I mean, we can call it a 510 because the range is 5'9" to 5'11". Very good, Jazz. Very good, Alexis, Tia. Yeah, y'all got it. So we want to be, for the average admit, we want to be between 5'09" and 5'11". So I'll take it when you say 5'10", because that doesn't sound off to me. And we will, at our boot camp on Saturday, we're going to dig into that just a little bit more with some data from the AAMC about their admitted students, and they're going to put GPA up next to MCAT so that we can see based on GPA what acceptance percentage you would be in, because while that is the average admit range, there is some play there with GPA. And I think sometimes we're like, well, my GPA is really high, so how low could I go on my MCAT, or my GPA is a little lower, how high do I need to go on my MCAT? So we're going to talk about all of those things on Saturday. But y'all are really good, really good. I think you were all right on point with that, so good job with that. This goes back over the science content. We talked a lot about the content of the test. I think that's been a running theme with us, is how much content we should study, how important is content, how much time should we spend on content, what content. And I think a lot of your emails to me have been about that too, and how to build your content study and build on past your content study, because content study really is that base foundation, and then we move into MCAT prep. But go ahead and take a screenshot of this if you would like, because I am moving on. This is my favorite slide, as y'all know, those of you who know me. This is my very favorite slide because it talks about all of the things that you need to be successful on the MCAT. And one of them is science knowledge. But there's so much other stuff. There's so much other stuff. Can y'all shout out anything that you've learned this week about the MCAT, or preparing for the MCAT, or any skills or strategies that maybe don't fall under the heading of content? I just want to make sure that we are thinking about all of the things besides content, because content is, I always say, it's the language. Science is the language that they use to speak to you and test you, but what they're really testing you for is logic. It's a logic test. It's a logic test about science. Good job, Honest. That's exactly what I was saying. Oh, Jazz, you know I love a good pattern. Listen, if you got a guess and you see an overlapping pattern, guess the market and move on. Exactly. Time management, Hideo, that's so important. And, also building that confidence so that we don't worry as much about timing. Oh, yes, easy questions first. I love it. I love it. That's how you're going to get your time because they're not going to give you more time on the test. But you can make better use of your time, and then it feels like you have more time, which is almost as good. Almost. Chunking, Peyton. I love chunking. That's where we're going to take it piece by piece, right? Because if you look at the whole mountain, sometimes it's overwhelming. But if you look at just the piece, it's like, well, I know this science fact, so maybe I can eliminate this one. I know this, and I can eliminate that. And then eventually you get there with the chunking. Oh, yes, Kaylee, I love that. Olympic-sized swimming pool, very long but not very deep. I've never thought about it that way. I think I'm going to steal that. Is it okay if I steal that for my students in the future? And we have talked about that a lot this week, too, that the MCAT does expect you to know a little bit about a lot of things, but they don't expect, like Teacher Tammy was telling you yesterday, they don't expect you to be a nephrologist just to talk about the kidney. It is a mile wide and an inch deep, the knowledge that you need. And I love that. I love that Olympic swimming pool. I think I really am going to steal that because y'all know I love a good analogy. Last night's homework, though, no analogies. It was a lot more like detailed. So I hope that you still liked that. I think the topic itself is just a little, I don't know if it's harder, but a little hard to put into analogy form, at least for me. So I hope that you enjoyed the homework that I sent out. And I did receive a lot of questions, so I did want to talk about that I did not include the answers for the upper portions of it. And that's because I can't. It's not my lesson to provide, but I did want you to have the information from the lesson so that you could answer the quiz that was provided afterwards. I know it was only 4 questions, but listen, if you need more questions and more quizzes, I know a really cool place where you can get them. It's right here. It's Kaplan. But I hope that you loved the homework and that you found it helpful and that you'll keep those notes too, because I feel like you can self-evaluate your performance on the earlier questions and then check that against the answered questions, which were the last 4. But that's what I have for you today. You know that we're doing the channel sessions until the boot camp. It's all MCAT channel. Does anybody know what I mean when I say MCAT channel? I feel like I've defined this a lot, but I want to make sure. Does anybody know? I know it's kind of weird. Like when we're on the website, I feel like I always see it and I'm like, MCAT channel, how would I even know what that was? What does that mean? But that's what we're doing all this week. Our MCAT channel is, of course, our elective lessons from Kaplan because we don't believe that any students need to study the same thing at the same time, at the same difficulty level, or even with the same teacher. Like we all have our favorite teachers and we all have people that we learn really well from, that we like to follow around. We all have different difficulty levels that we're working on. Some of us are working on advanced this or beginner that, and all the way around. And so our MCAT channel is where we host all of those elective lessons so that we can make sure that every single one of our students gets live instruction on whatever they need. Now we have over 100 of these actually, and this is in addition to the classes that we have that you see scheduled on our website, and they're kind of free for all. You can take all of them, you take any of them, or you can let your plus coach help you decide which ones are best for you, because that's kind of what I do. That's what I like to do. But we're having one of those today, and we're doing today's light and optics lesson from the MCAT channel. And our teacher today is amazing. If you have been coming to our events for a while, you've probably seen her. She is fabulous. Her name is Teacher Kristen, and she is amazing. And I can't wait for you to meet her and then tell me about how awesome it was afterwards. And so that you know, our post-class coaching session today is going to be about memory and retention. And I think it's great because 1, it's a psych-soc topic, so we're putting a little MCAT in your coaching today. And 2, it's very relevant to what we're doing, right? Because we are trying to build learning and memory for our MCAT. So I hope that you will stay tuned for that. But for right now, it's time to say a big hello to tonight's teacher, Kristen Russell. She's going to lead you through your light and optics. It's going to be awesome. And I'll be in the chat answering questions or making silly jokes with Ashwarya. And I will see you later. Bye-bye.
Hi everyone, let me know that you guys can see and hear me, and we're gonna get started. My name's Kristen. Allie just gave me an awesome intro, so who's ready for some light and optics tonight? I think it's gonna be really fun, although I know a lot of students do not share my love of physics, so physics. It is tough. I get that it's one of the harder topics, but if you can master some of the small things that are high yield in terms of physics for the MCAT, then you can really have bang for your buck in the Chem Phys section. So we're going to have some fun with this. We are going to try and simplify a lot of the light and optics topics that may have confused you in the past, and we're going to have some fun with it. So I have a little notepad on screen, and that's something I'm going to be pulling on and off at different times throughout the lesson to try and summarize some of the main points for you guys. So I'm just going to name this Notes for You, and I will give you a chance to kind of screenshot those at some point if you would like to. So we'll bring that back up in a little bit, but let's go ahead and dive in. We have two main learning goals that we're going to be talking about tonight. The first one we're going to touch on is talking about the components of the electromagnetic spectrum and the properties of light. So you've probably seen before the entire EM spectrum. Now, do you think for MCAT purposes you're going to have to memorize everything on the EM spectrum, including the frequency and wavelength? Do you think you're going to have to do that? Because that sounds kind of not fun. I don't know about you guys, but that sounds not super fun to me. Now, the second learning goal we're going to be touching on is going to be applying our knowledge of reflection and refraction to a couple of applications. We're going to look at ray diagrams, and we're going to be doing that for both lenses and mirrors. So it's going to be a pretty fun next hour to hour and a half. Now, I see you guys in the chat saying no, or I hope not. And you are correct. You do not have to know the frequency and the wavelength of everything in the EM spectrum. I will tell you exactly the things that you need to know from the spectrum and then the things that you don't really need to know. So let's go ahead and dive into that first learning goal where we're going to look at this in a little bit more detail. Now, don't let this chart right here scare you because it does show off a lot of different numbers. But the point of this is to show you that we don't have to know both frequency and wavelength. We just need to know that they are going to be inverse. So what is the equation that relates frequency and wavelength? What equation is that? Now, the one thing you're going to have to know lots about here is where visible light is. So the little rainbow you see in the middle of this guy, this is something we're going to talk about in a little bit more detail than the rest, but let's give you kind of that big overview, and here's that equation. Here's that equation right here, and I see a lot of you guys now throwing it in the chat. You got it. We are going to take the velocity or the speed of light, and we're going to say that's equal to frequency times wavelength. So this is how we get that relationship between frequency and wavelength being inversely proportional. Now, if you ever look at this and you are confused about how we use the unit hertz, and we multiply that by the unit of meters, and we somehow get meters per second. Well, that's because hertz is also the same as 1/seconds. So that's how we can multiply frequency by wavelength and get meters per second. Okay, now one of the few things that you actually have to memorize in terms of values of constants for the MCAT is the speed of light. That is one that you'll want to know. So give me that value in the chat. Let's see who's got it. I'm going to start showing you some stuff on the spectrum. So decreasing frequency and energy, increasing wavelength. So again, inversely proportional. There is an equation that relates energy and frequency. Let's see if any of you guys know that one as well. I like testing you to see what you know already. All right, we got it. A lot of you guys now coming in with the value for the speed of light. It is 3 times 10 to the 8th meters per second. We got it. Very nice. All right, let's see if you guys know that relationship between energy and frequency. That's the next one I want to see. Okay, so again, visible light. This is going to be a huge one for us to know a little bit more about. Now, some of this you will be expected to have memorized. Now the rest of this though, gamma rays, X-rays, UV, IR, microwaves, and radio waves, you don't have to know the exact values for the wavelength of all of these. What you should know though is their general relationship to each other. So you should know, for instance, that gamma rays have a really, really tiny wavelength and radio waves have a huge wavelength. Those are the things that you will have to know. So you'll kind of want to know where things are located on the spectrum, but not the values that go along with them. And of course, you guys are coming in with the answer that I'm looking for, the relationship between energy and frequency. Nice job, Arette and Kira, and Kenzie's coming in with a different form of it. Our equation is E equals HF. E equals HF. H is a constant, you don't have to know it. But this shows you the relationship that we're seeing right here, where we're seeing that frequency and energy are going to be doing one thing, while wavelength does another. E and F are directly proportional, and F and lambda are inversely proportional to each other. Okay, so let's look at the visible light spectrum in a bit more detail. These are the values, again, that you are going to need to know. So let me just ask you guys, do you know the range of wavelength values for the visible spectrum? And I also want you to tell me which unit of meters do we normally use when we're describing the visible spectrum of light. Now, of course, you could keep it in meters, and you could use a times 10 to the negative something, but oftentimes we do use one of the other units to describe this stuff. So Jazz says 350 to 750, and Hemantha says 740 to 400 nanometers, and nanometers is the unit that I was talking about. Typically, we're going to describe things from around 400 to 700 nanometers, and more specifically, we can see here the exact values. 380 to 750 is the range we're looking at. Now, if you're using something in scientific notation, then you are not going to say it this way, of course. So if you're looking up here and you're seeing, well, how are we getting times 10 to the negative 9th here? Because when I look at this, I see this thing is right after 10 to the negative 6th. Well, remember 450 times 10 to the negative 9th. How would we convert that? How would we convert that guy? 450 times 10 to the negative 9th meters. Well, to put that in scientific notation, I would need to say 4.5. Now, the quick trick in how to convert that stuff, if you're not super duper comfortable with that, if you make this number smaller, then you need to make this number larger, and I mean the overall exponent. So converting this, we would say 4.5 times 10 to the negative 7th meters, okay? So you can totally just convert that right out. That is typical, though, to see it written in nanometers instead of written as like 4.5 times 10 to the negative 7th. That's not usually how we're going to see that written. Now, you guys probably know the mnemonic to remember the visible light colors, and they're the colors of the rainbow. We're going to use Roy G. Biv to remember these things. So again, we're going to see decreasing frequency with increasing wavelength, the same type of relationship we saw before. So we are going to see that red has the longest wavelength, and we're going to see violet has the shortest wavelength. Now, this makes pretty good sense considering that we're going to see UV, which is ultraviolet, and IR, which is infrared, right on each side of the visible spectrum of light. Now, the ones in the middle, we're going to use, like Jazz is saying down there, we're going to use Roy G. Biv to remember all of these. Okay, now I said that you are expected to know a lot of the values associated with the visible spectrum of light, but do you need to memorize the exact wavelength for each of these? Probably not. What I recommend you do is know kind of the upper and the lower end, and then know one value in between, and you can kind of estimate the others. So you should be thinking maybe roughly 400 for violet, you should be thinking maybe roughly 700 for red. Of course, there are many colors of red that you can see here, so we're kind of getting, you know, multiple options for red. But usually I say around 700 red, around 400 violet, and then maybe look at green as your in the middle value. And so green, you're looking at maybe 550. And then anything else, you can just estimate that it's something between those values, okay? So that's what you will want to know about visible light. And let's go ahead and test our knowledge of it and see if we can score a point on an MCAT style question. So don't panic looking at this thing because this definitely looks long. It looks a little bit overwhelming. I'm going to give you guys a moment to read the question stem. Do that now. Okay, it's a mouthful, right? There's a lot going on here. Well, let's try and break it down. So we see elevated wakefulness has been heavily tied to exposure to blue light. Okay, so in my head, I'm already thinking, and if you wanted to write this down as you're going on your scratch paper, you could do that, but you don't necessarily need to. I'm just kind of thinking this as we go. I would think, okay, well, wakefulness, I'm going to increase wakefulness if I have blue light. So blue light and wakefulness are tied together. Okay, then it tells me how it does this. So this long piece right here on these fibers, the locus coeruleus is channeled opsin 2. This part really ends up not being important to what the question's asking. So what you can do, and this is kind of like one of those pro tips, when you have a super, super long question stem like this, it is a good idea to go ahead and look ahead to the last part of it, the long blurb of text. Oftentimes, this last part is going to tell you what the question wants you to do, and that is the case here. Now, you're going to have to go back, of course, and read the other info, but this at least helps you determine what is and what is not important. So the thing we want to know is which of the following ambient settings would be least effective in supplementing treatment of insomnia. So now you can definitely say this whole thing about locus coeruleus is not important. We don't need to know that in order to answer this. We just need to know that wakefulness is associated with blue, and so we want to determine which setting is not going to help with treating insomnia. Now, the way that's worded is a little bit tricky. So let's think about that again. If we're treating insomnia, would we want to promote wakefulness? Well, no, we'd want to promote sleepiness. But this says we want the thing that's going to be least effective in treating insomnia, which means we are looking for something that, in fact, does promote wakefulness. So we want blue. Okay, so totally, Adrian, we're going to look at the blue part to know what we're looking for. Now, we kind of made an estimate before of where blue is going to live on the spectrum. Of course, you know, there are different values that you could pick, but we said somewhere between like 400 and 550 would be where we're kind of looking for blue to live because we estimated violet and green. Okay, so we take our estimate value and we're going to plug it in. Somewhere between 400 and 500 is what we normally say for blue. So let's go ahead and plug in 450. Now you can see here, instead of actually writing in 450 nanometers, it's helpful here to put things back in scientific notation. So putting things back in scientific notation allows us to work with light in meters per second because we want these units to end up in 1/seconds for a frequency. Okay, so what do we do from here? Does anyone get a little nervous with doing this kind of math without a calculator? I know that when I was first studying for the MCAT, I thought, I haven't done math without a calculator since like middle school. Are they really expecting me to do this by hand? I was, you know, glued to my calculator throughout undergrad. I was an engineer, so we did lots of math, but I had my graphing calculator at every turn. And so, you know, I was very comfortable that way, but not by hand. So it's something you kind of have to knock the cobwebs out of your brain to get comfortable doing that again. It's the worst, Julia, I know, but you will get more comfortable with it. So what we want to do is handle the front, which is called the mantissa, and the back, where we're looking at exponents, separately. Okay, so we start off here and we've got 3 divided by 4.5. Okay, well, we don't need to be exact here, but 3 out of 4, well, we're looking at 7.5. Okay, 75%, 3/4. That's pretty close. We don't have to be exact again. So when you guys look at the answer choices, is there anything you feel comfortable we could say is not going to be correct at this point? Even with that really minimal effort, super minimal effort. Well, we said maybe we're looking at 0.75 here for this front part. Well, of course, we'd have to convert it back into regular scientific notation with the 7.5. But yeah, 2.1 and 4.7, that doesn't seem like it's going to be right. So again, super minimal effort, and 2 of those are out of there. Okay, well, now we have to deal with the back half. So how do we handle exponents when we are using division? What do we do? What do we do with those? Well, we are going to have to subtract off the bottom one. So we're going to say 10 to the 8th minus a minus 7, okay? So when we do that, we're going to have 10 to the 15th. Okay, so at this point, we have 0.75 times 10 to the 15th. Well, you guys know that is not in the answer choices. It's not over there because we want this in scientific notation. So we're going to do kind of the same thing I showed you guys before. We, in this case, though, want to make this bigger. We want to go from 0.75 to 7.5. So what we need to do is make the exponent smaller. So we are looking for something approximately 7.5 times 10 to the 14th. And with that said, our correct answer here has got to be answer choice D. So again, minimal effort got you down to 50-50, and if you had enough time, you would do this math, which ends up not being that bad at all. Looks worse than it is. Awesome job, you guys. First question down. First question down. And now we get to move into, I would say, the more exciting of the 2 learning goals. The first one was kind of a nice little warm-up, but this second one is going to be super fun. We are going to be looking at ray diagrams for mirrors and lenses. Now, do any of you guys feel like potentially you have no idea what the difference is? What should be the same? What should be different? Converging versus diverging. How do I memorize each of those? Definitely can be a little bit tricky, but I'm going to try and clarify and show you some patterns. I know Allie loves to find patterns when it comes to MCAT, so we can do the same thing with some content, and we're going to look for those patterns here. So in order to kind of understand the different laws, we need to talk about reflection, because we're going to be looking at mirrors first. Okay, so reflection. What describes how reflection of rays will work? What does the law of reflection say? Well, it has to do something with light bouncing off. What's the angle going to be? If we have a light ray approaching a mirror, what is it going to do? What's it going to do? Well, it should bounce off at exactly the same angle, okay? So we can see an incoming angle, which we might call theta 1, and that's going to be equal to the outgoing angle, theta 2, okay? Now, let's talk about plane mirrors, and I don't mean like plane like boring, I mean plane like in the same plane. So maybe you get ready in the morning in front of a mirror while you're brushing your teeth. You probably have a mirror somewhere around. The image you are seeing of yourself in the plane mirror, is that a real or a virtual image? Let's see if you guys know. I'm going to give you some clues about what we mean by real and virtual. A real image is going to be inverted. It's inverted. And real means where light rays actually converge. Okay? In order for it to be real, that means rays of light come together there. Well, the fact that you don't see yourself upside down in the mirror probably gives you a clue here that it is not a real image. So plane mirrors always create virtual images. It's not very often that I get to use the word always. I feel like science loves exceptions, but this is a case where we can. Plane mirrors always create virtual images. Okay, so to define virtual then, a virtual image is going to be upright, and it's going to be where light rays don't actually meet. Okay, now when we start to get into our ray diagrams, we can see that a little bit more. I'll show you what we mean with a virtual image. But when you see yourself in the mirror every day, because you're seeing yourself right side up, you know that you're seeing a virtual image. Now, another way you can play around with this, and I actually don't have a mirror next to me right now, but you guys can try this after class today. So I want you to walk up to a bathroom mirror. I want you to stick your finger right up to it. And I want you to look and see how far away it looks like the image of your finger is. Well, you're never going to be able to get it to actually touch the image of your finger, because it's behind there, right? You're seeing an image behind. So it's always going to look double the distance away. So for instance, if you stand 5 feet from a plane mirror, a full-length plane mirror, how far away does your image appear to be? Well, it's going to be double. It's going to be 10 feet away. So that's a good way to kind of just know that going in and have some knowledge of plane mirrors. It's going to be twice the distance away you actually are from the mirror. So you could say really that the image and the object distance would be 5 feet. Okay, so this is simple. Plane mirrors, they're the easiest way to go, but really what we're going to be dealing with on the MCAT is spherical mirrors. However, knowing this background is going to prove to be super duper helpful. So let's look at spherical mirrors and start to define the different things we're going to see in a diagram. Ooh, Jeremiah, so images are closer than they appear. That does not apply for plane mirrors, but that is going to apply for a spherical mirror we're going to see here shortly. So I'm glad you mentioned that, so we can remember that when we come to that section. Okay, so when we're looking at ray diagrams and just a diagram in general that shows a mirror or a lens, there are a couple of things to pay attention to. We're usually going to see C and F here, or at least read about those terms if a question asked about them. So F represents the focal point, and little f, or if it's a distance that it's describing, that would be the focal length. Now C is the center, and we can talk about the distance from the mirror being the radius of curvature. Now, an object is usually going to be drawn as a little arrow upwards, and then we have a distance to the mirror that will be described as the object length. We then will have another arrow drawn for the image. Now, the arrow can be pointing down or it can be pointing up, and that's showing you, is it upright or is it inverted? Okay. Then you will have another distance to the mirror that describes the image distance. Okay. Now, these things are going to be important to know what they are, so that when we're drawing a ray diagram, we can quickly interpret what we're looking at. And you also want to be able to take text and interpret a text-based version into a diagram so you could figure it out. Now, if any of you here are like, man, ray diagrams, I really don't want to have to deal with those. Can I just like remember certain options that it could be and figure it out from there? And the answer to that is yes. I'm going to show you guys that there really aren't that many scenarios to memorize if you would prefer doing it that way. But of course, we're going to spend some time on ray diagrams because I actually think they're kind of fun. Now, this equation in the bottom right now, focal length, 1 over f equals 1 over o plus 1 over I. This is something you should definitely be aware of, and we are going to look at a question involving that equation a little bit later. However, if you stumble across a question on test day that involves that thing, you may decide to triage that thing and come back to it because it can be a little bit rough to interpret, to plug in, and to solve. So triaging would not necessarily be a bad plan. Now, magnification is the other thing we're going to talk about. We'll talk about, is this thing the same size? Is it magnified or is it minimized? And you can look at that using the equation m equals negative I over O. Those are the two important equations you guys should be familiar with, but fortunately there aren't too many equations to memorize when it comes to lenses and mirrors. All right, so let's take a look at our first situation. We are going to be looking at concave mirrors first. Now let me describe to you the difference in concave and convex. Concave literally looks like you are walking into a cave. So light is coming this way, and if you were standing there walking in, it would look like a cave. Now convex is just going to be the opposite of that. That's going to be convex. So this is our concave mirror. Let's see what's going to happen. Now, there's going to be potentially more than one scenario for each shape of mirror, but this is going to be the first one. So in our first example here, we are going to say the object is placed between the focal point and the center, okay? Now, if you recall, what are the rules that describe the different rays we're going to draw on this ray diagram? What do you recall? Well, there are 3 that you could draw, but really we only need 2 of them because the whole point of a ray diagram is to find where rays come together, where they converge. So Jazz says we're going to draw one perpendicular. So I think you mean we're just going to draw it right off of where the object arrow is and straight to the mirror, okay? So it's going to run parallel to that center point, if you will. So parallel, and then it's going to reflect back through the focal point. Then our second ray, we're going to draw it to the center of the mirror and back at the same angle. So from the object, the tip of the arrow, to the center point of the mirror and reflect back off. Okay, well, we see a point where those rays converge, and that's going to be where our image is. Now, you guys are totally right for the third one. If we were to draw a third one, the third one would be from the object through the focal point and then back off in a parallel form. So let me kind of draw it on here if I can draw straight. We'll see if I can do it. So we'd kind of be drawn right here. We'd come down, and then we'd draw this thing like off at a straight line. And you can see that it would also converge in kind of the same, in exactly the same place. It's kind of in the same place when I drew it because in my drawing I didn't have a ruler or anything. But you can see here that they would all come to the same place. So we could really put that third one up here if we wanted to. So that would be, again, from the object through the focal point, back parallel from the mirror. Okay, that would be the third one. But again, you only have to draw 2 of those. Okay, so I want you guys to describe to me what we know about the image that is formed. What can you describe to me about the image that is formed? Well, knowing that they're converging below that center point axis definitely tells us something, right? We know that it is upside down. It's inverted. So that means it's real. Now, again, this is something I love being able to tell you always. We can say that inverted is always going to be real. Inverted is always real. And it's kind of funny, but you can remember here, remember we talked about infrared IR? So you can remember IR. And then upright is always going to be virtual. Always. And you can remember that one, guess what? UV. So those are kind of like dual purpose for you here. Okay, so this image, like you guys told me, is going to be real. It is going to be inverted. And Daniela tells me here that it's going to be magnified. How can we tell it's going to be magnified? How do we know it is going to be magnified? You're correct that it will be. How do we know? Well, take a look at the length of that arrow compared to the arrow for the object. The length of that actually determines the size. So if we had an image arrow that was exactly the same size as the object arrow, then the image would be the same size as the object. But because that arrow is so much longer, then we know it's going to be magnified. So guess what? We did our first one, and we're going to keep track of some of this on the little notepad I brought up for you. So let's go ahead and write in a few things. That way you can come back to them later. So we'll write in our always statements. Plane mirrors always produce virtual images. We can say inverted images are always real. And we can say upright images are always virtual. We'll start with the fun always statements. Okay. Now we can say that a concave mirror is converging. Okay, concave mirror is converging. Now we have three different scenarios that we're going to pay attention to when it comes to our concave mirrors, and we just talked about the first one. So in scenario one, we have object between F and C. So between the focal point and the center. Okay. Object between F and C. And when we had that, we got an image that is real, inverted, and magnified. Okay? I'll make this a little bigger in case you can't see it very well. All right, so that was scenario one. You could either memorize that scenario, between F and C, images real, inverted, and magnified, or you could draw the right diagram and prove to yourself what it looks like. Okay. All right, so that was scenario one. Let's take a look at another one. So in scenario two, we're going to say the object is at the focal point. Okay, so we're going to use our rays. We're going to draw one that is parallel, and then we're going to come back through the focal point. Then we're going to draw one to the center and back off at the same angle. You guys tell me, does it look like those two rays are going to ever converge? When I look at it, it kind of looks to me like they are parallel. I don't know about you, but to me, they look parallel. Well, if they're parallel, they're gonna stay parallel, which means those things are never gonna converge. Okay, well, never and infinity, those things can kind of mean the same thing. So in this case, let's see what that would mean. So if like this thing after, millions and millions and millions and millions of miles were to converge, we could say that's at infinity. So what would the size of the image be if these things did converge at infinity? So let's say really, really far away, somehow these things came together at infinity. What would be the size of that image? So just imagine that they're converging way down there. So this arrow you're drawing looks like that all the way down here. So we could say here that it's infinitely magnified. So there are kind of two ways to describe this situation. We could say these are real, inverted, and infinitely magnified. So it's real at infinity. Or the other way we can kind of say this, and this is also correct, we would say no image, because we're not really able to see infinity, okay? So let's take note of this scenario as well. We have scenario 2, where the object is at the focal point, and we're going to say image that is real at infinity, inverted, and infinitely magnified, which we are going to say is the same thing as no image. Functionally, that means no image. Okay, so we've drawn ray diagrams for scenario 2, and we have our scenario written down here in our notepad. So we could choose to memorize that if that is your preference. Okay, let's take a look at our third scenario for our concave mirror. All right, here we have an object that is between the mirror and the focal point. Okay, let's draw our rays again. We're going to draw to the mirror and back through the focal point, and then we're going to draw through the center and back off. Okay, we have a problem here because it does not appear that these are going to come together. What we have to do, though, is draw them backwards. Okay, so if we draw back through the mirror, we're going to see that they will converge. Well, let me ask you this. Does light actually pass through a mirror? Does light pass through a mirror? No, it should reflect off. So this is a signal to you that this is going to be a virtual image, because remember when we were defining these, we said virtual, light rays do not actually converge there, okay? So this is going to be a virtual image that is behind the mirror. It's going to be behind the mirror. And we know from looking at where that little arrow is going to be that this thing is upright, which means if it's upright, it is always virtual, okay? So we could describe this, and that little arrow drew a little funny, just kind of showed up in the wrong spot. So let's draw it in the right spot. It's going to be right there. And so we would describe this image as virtual, upright, and magnified. Okay, virtual, upright, and magnified. So scenario 3, we've got object between mirror and F. We're going to say image that is virtual, upright, and magnified. Okay, not so bad, right? That wasn't so bad. 3 scenarios. Okay, let's take a look at our other type of mirror, and then we'll do a summary and kind of compare them. Okay, so our other type of mirror is a convex mirror. Now, convex mirrors are diverging, and we're going to see what that means. Okay, so let's start with our object. We are going to draw parallel and through the focal point. But based on the shape of this mirror, which focal point should we draw through? Which focal point should we draw through? Well, we always want to pick a focal point that's kind of like in between the mirror and the center. And you can kind of imagine what this would look like if we were to draw this out as a total circle so that we could figure out where the center is. If we did that, we would need to use the focal point that's like on the far side, if you will, behind the mirror. You got it. All right, so we draw it out and through the focal point. So we kind of visualize this part, but we know that, of course, it's a mirror, it's going to reflect, so we're going to bounce off. Okay, well then we're going to draw another one through the center and reflecting back out. Okay, well, these are not going to come together on the real side, but they will converge on the virtual side. Okay, now this is again why we call this thing a diverging mirror, because diverging mirrors are always going to diverge light rays. We will see those like fake light rays converge on the other side of the mirror, so this thing is going to be a virtual image. What else can you tell me about the image that's different from all of the other ones we looked at? Well, guess what? This is the only one that is minimized. This one is going to be a little guy. So this image is virtual, it is upright, and it is minimized. Now, I'm going to go back to what you guys mentioned about car mirrors. What does the car mirror say again? What does it say? I'm going to start writing this one in here. Convex mirror is diverging. We only have one scenario here. This is awesome. So we can say in all convex mirrors, regardless of object placement, we are going to get the same thing. Okay? So the one scenario is going to be image that is virtual, upright, and minimized. So yeah, it says images, or no, it says objects are closer than they appear. Okay, objects are closer than they appear. Well, what that means is the image you're seeing looks small, which in your head tells you that that thing's far away, right? That it's much farther behind you. But because objects are closer than they appear, it tells you that that image you're seeing is minimized right there, okay? So guess what? All of them look like that. Now, there are lots of places that are going to use these diverging mirrors to take benefit of that. So convenience stores often have that so that, you can look around and see the entire store. Parking garages, the hospitals where you have tight turns and people might be flying down with stretchers. You have a lot of diverging mirrors in those situations because it allows you to see a lot more. But everything you see in there is smaller, and we just showed why that would be. So we're seeing here that convex mirrors are quite simple. There are not a lot of scenarios we have to memorize. So let's kind of summarize everything we just did here. Okay, so I'm going to make this a little bit bigger. Now, we saw that for converging, we had a few scenarios we had to pay attention to, but in all of them, we are seeing something that's magnified. Well, in a convex mirror, we only had one scenario, but they're always minimized. So we can see the pattern there. Now, with concave mirrors, if we are at the focal point and beyond, we are going to see real images. If we are in front of the focal point, meaning between the focal point and the mirror itself, then we were seeing something that was virtual and upright. So 3 scenarios for our concave mirror, and again, 1 for convex, that's diverging. Now let's talk for a moment about how you would use the equation 1 over f equals 1 over o plus 1 over I. Okay? We're going to talk about how you might use this. Now, f is focal length, but one thing that they will try and potentially confuse you with are the sign of these. Is it plus or minus? So we're going to use a plus sign for focal length if we're talking about something that is converging, and we're going to use a minus sign for focal length if this is something diverging. Okay, object. Object is almost always going to be positive. It's almost always going to be positive. The only time it would not be positive is if you had an image that is the object of a second mirror. So like really weird situation, you're almost always going to have a positive object. Now for image, let's talk about this for a second. You can have positive or negative image distance. Now it's actually pretty easy how it works out here for our mirror. Tell me where you would expect light rays to go. The same side as the object or the other side of the mirror? Where would you expect light rays to go? Well, you guys told me that reflection is what we're working with here, right? That would mean for a mirror, they're going to reflect light rays back. So we would expect the light rays to be on the same side as the object. So we would consider a positive image distance for a mirror to be one where image is going to be on the same side, okay? Same side. And this is just based on what we said about where light rays go. Now, again, we saw examples where virtual could produce an image on the other side, but we expect light rays to be on the same side as the object if we're talking about what reflection does. And that's a good way to kind of remember the sign convention. So a positive image distance for a mirror means the image is on the same side as the object. Negative means image is on the other side. So the one that's on screen right here that we're looking at, this diverging mirror, is going to have a negative image distance. So in this example, actually, we'd have a positive object. We would have a negative focal length because it's diverging, and we would have a negative image distance. That's how the sign convention works when we're using that equation. Okay, let's summarize that real quick in our notes pod, again, in case you want to grab any of this stuff for later. So for mirrors, positive focal distance is going to be for converging. Negative focal distance is going to be for diverging. We are going to see almost always a positive image distance. And then again, for a positive, almost always positive object distance. I bet someone caught that. Okay, a positive image distance is going to be image on same side, and a negative image distance, image on other side. All right, cool. We made it through one of the most challenging parts. Who's ready to look at some lenses? You guys ready? We're going to have some fun with lenses as well. And then after that, we're going to tackle some practice questions to see how you guys are faring on this material. So let's dive into lenses. Now, what's the biggest difference with a lens and the way it behaves with light? What's the biggest distance we're going to see with the behavior of light when we start looking at lenses instead of mirrors? I'm going to wait for you guys to tell me. We're going to see a huge difference in behavior. And that's really going to define a lot of the things we're going to discuss when we start looking at lenses. So, Chris, we are going to see again convex and concave. Yeah, Lisa, you got it. We're going to see light pass through. So the expectation is that instead of reflecting off like a mirror, we're going to have light pass through. And so refraction is going to be what's super important here, okay? Now, we're going to talk briefly about Snell's law, though we're not really going to have to pay a ton of attention to this when we just talk about our ray diagrams, but this is certainly something that is MCAT testable. So refraction is going to kind of be talking about the way that light is going to travel through different media. So if we were talking about something going from water to air, we need to pay attention to the indices of refraction for water and air. So water is going to have a higher index of refraction than air, and that means light is going to travel more slowly through water than air. So when we hit that interface with water and air, we're going to see the light ray bend away from normal. So normal is just this perpendicular line, this one right here. So as light travels into a medium with a smaller index of refraction, we are going to see that ray of light bend away from the normal. Okay, so the angle essentially is getting bigger. The angle gets bigger. So again, the angles we're comparing would be, we'll call this guy theta 1. And then this one would be theta 2. So we could summarize that by saying that N2 is less than N1 because air is the second medium that it hits. So this would be N2 up here, and water would be the N1. So N2 is less than N1 in this situation. So we're going to see light starts to travel faster, which is the same as bend away from the normal. Okay, well, I guess you can imagine what's going to happen then if we had a situation in which N1 is greater than N2. Well, that would be like the opposite if we were traveling from air into water. So we're going to see light starts to travel slower. And this would be bend toward normal. Okay? Now, bonus points for anyone who can tell me Snell's law in the chat. Let's see if you guys can get it. You got it, Chris. We're just looking at like the other version of this. Air to water or water to air. Jazz, you got it. Nicely done. Very nicely done. We've got N1 sine theta 1 equals N2 sine theta 2. That is Snell's law. Okay, now I want to show you guys something that has always been super helpful to me, and it might be helpful to you if you've ever had trouble trying to recall the different angles and the sines and cosines of things. So I'm going to pull up something real quick, and it's going to cover up my face really quickly, but then I promise I'm going to move it out of the way so that you can see me again. There we go. All right, so I'm going to bring up a whiteboard, and this is one of my favorite tricks ever, okay? You guys have to bear with me, though, because I'm going to draw something and then try and show you what I'm talking about. All right, I'm not the best artist, so be patient with me if you can. So I'm going to try and draw a hand, and that should be simple, right? Okay, so here's a thumb, and then we're going to draw pointer finger, middle finger, ring finger, and pinky, okay? So this is your right hand, and you're looking at your palm, okay? Not the back of your hand, but your palm. Now, there's a couple things we need on this just to kind of help us work through this little hand rule, okay? So I'm going to write those up here. We're going to assign angles to each of our fingers. So 0, 30, 45, 60, and 90. Then we are going to say that our thumb side, which I'm just going to put a little T here for thumb and a little P here for pinky in case my drawing's that bad that you can't tell. Okay, so our thumb side is going to be our sine side, and our pinky side is going to be our cosine side. Now the last thing we need on our little chart here, we're going to imagine a giant square root floating over our hand, and then on our palm, we're going to imagine divided by 2. Okay, so now we're set up. And I'm going to use my hand to help you, but I'm going to turn this way so that it looks normal to you, so we're not getting a weird image, okay? So if I wanted to take the sine of 30, if I want to take the sine of 30, I am going to drop this finger, my pointer finger, because this is 30. Okay, so I drop this guy. Now, remember, this is the sine side on this side where my thumb is, and there's one finger remaining. So I'm going to say the square root of 1 divided by 2. Now, the square root of 1 is 1, so it's going to be 1/2. So the sine of 30 is 1/2, which is correct. Okay, let's do it for another one. Let's say we're going to do the sine of 45. So we're going to drop our middle finger. Now there are 2 fingers remaining on the sine side. Okay, so it's going to be the square root of 2 divided by 2, which is correct. Let's do it again. Let's do the sine of 60. Okay, so I'm going to drop that finger. There are 3 fingers remaining on the sine side. So it's going to be the square root of 3 divided by 2. What do you guys think? Working out pretty well? Let's see if we can do it for the sine of 90. Okay, pinky's 90. 4 fingers remaining. Square root of 4 divided by 2. Okay, well, the square root of 4 is 2. 2 divided by 2 is 1. And that is correct. The sine of 90 is 1. Okay, well, let me show you how this works for cosine as well. Cosine. Okay, well, cosine's on this side. So let's say we want to take the cosine of 30. So I drop this finger, but now I pay attention to how many are left on the cosine side. So the cosine of 30 is going to be the square root of 3 divided by 2. The cosine of 45, square root of 2 divided by 2. Cosine of 60, square root of 1 divided by 2. Isn't that amazing? I wish I could take complete credit for this, but I learned this from a teacher when I was first getting into this kind of math, and I've used it ever since. So, I mean, it feels like years and years and years. I mean, I can take credit for sharing it with you guys, but I can't take credit for inventing it. But it's awesome. I've just never forgotten my common angles for sine and cosine since learning this trick. You can totally use this on test day. Just don't make your hands all crazy, kind of keep them in front of you. You don't want the proctor to think you're trying to signal someone next to you, which I don't know how you would signal someone, but people have probably tried to do it before. Yeah, isn't this trick amazing? I love it. It's so awesome. Okay, so I kind of took a quick aside from light and optics to show you that trick since I love it so, so much, but it can be helpful with Snell's law when you have to figure out for certain angles. Now, they're not going to give you some crazy angle like the sine of, 81. They're not going to do that. So you're going to be able to use the common angles. Okay, so we've talked about refraction. We've talked about Snell's law. We've talked about the awesome hand trick. Now we're ready to dive into our lenses. Now let's bring up our special little notepad here. And we're going to put lenses at the top now. So what I'm going to do is just make some space here. All right, so we are going to start with one of our lenses. Now, lenses are going to be a little bit different in the way they look, okay? So what we're going to see here are two sides of this. So you might be thinking, well, the first thing we come across, if light was coming from this way, this thing kind of looks like it's concave, but the next thing kind of looks like it's convex. Well, that seems weird. So how do we actually describe this one? How do we describe this guy? Is this concave or convex? The way that I kind of remember this, and it's just a little bit of a trick that works for me, the first side you come across, is going to be the one that you use to describe this shape, okay? So this one, first layer, I guess you could say, describes shape. So in this case, this one we would say is convex, okay? Now the second layer you come across, second layer describes function. Okay, so that first one is convex. The second one we come across, we're not going to describe as a shape, but we're going to describe this as converging, because the shape we come across here is going to have this action on light. It's going to make light rays converge. So in this one that I drew, and the one that you're seeing that we're going to draw a ray diagram for, this is convex and converging. Okay. Now, if we had the other shape that we're going to see, which looks like this, we'll do the same thing. The first layer we come across is going to describe the shape. So that shape looks concave, right? So we're going to call this concave. And the second layer we come across is going to do the diverging action of light rays. So this is concave diverging. So this is one of the things that is different between our lenses and mirrors. And I just realized you might not be able to see all of this that well, so let me move it down. There we go. Okay. It's actually not, Opinder. It's actually not. We are going to see that convex is converging for lenses. So we'll write that up here as one of our first differences, okay? So for lenses, convex is converging and concave is diverging. Then we'd say for mirrors, convex is diverging and concave is converging. So that is one of the big differences between them, okay? Now, from here, we can focus on what our ray diagram is going to do. So let me move this stuff even farther down so that it doesn't get in the way at all. Make it a little smaller. All right, so let's draw our ray diagram. We're going to start with an object that is between the focal point and the center. Okay, we're going to draw the same type of rays. The only difference is instead of reflecting, they're going to go through. So we are going to draw parallel and through the focal point. And then we are going to draw through the center. Okay, through the center. All right, so I want you guys to describe to me, what you would say about this image. When you describe this image to me. Well, it looks like it's going to be upside down, and we know that inverted is real, and it looks like it's going to be bigger, so that must mean it's magnified, right? Sana, Salam, you guys got it. It is real, inverted, and it's magnified. So what we're seeing here is this is actually the same scenario as for the concave mirror. Interesting. Okay, so we would say here for our convex lens, which is diverging, we're gonna, concave, I totally said this backwards for you. Concave lens is converging. There we go. Concave lens is converging. Scenario 1. Object between F and C, we're going to see an image that is real, inverted, and magnified. So guess what? Same thing. Same thing. Let's see here. For our second one, what do you guys think the scenario is going to be? What do you think the scenario is going to be? It's going to be the same as our last one. All right, so in our second scenario, we are going to have an object at the focal point, okay? Now in this case, we are going to draw the same type of rays, parallel and through the focal point and through the center. If any of you guys can't see what I'm typing, I'll make sure to make it really big at the end, but I'm just typing the same thing I'm saying, so I'll make sure you have a chance to like screenshot if you'd like to. All right, so for this one, how would you describe the image or potentially lack thereof? How would you describe this guy? Same thing as last time. We have an object at the focal point. When we have an object at the focal point, we are going to say that the image is real at infinity, inverted, and infinitely magnified, which is the same as saying that we have no image. Guess what? We're just following what we saw for mirrors. Okay, let's look at our third one. Here, I think you guys are not going to be too surprised to see that the object is between the lens and the focal point. So we're going to draw parallel and through the focal point. We're going to draw straight through the center of the lens. Now looking at these, we can say they don't look like they're going to converge. So we're going to draw them backwards And the reason now that we're on the same side as the object is because, remember, we expect for lenses light to pass through, whereas for mirrors, they should have bounced off. So that's the biggest difference you got to kind of think of when you're thinking lens versus mirror. All right, so when these guys come back together, we're going to see that it's upright, it's going to be virtual, and it's going to be magnified. So we have the same third scenario for our lens. So we'll make note of that one. Object between F and lens, we are going to see an image that is virtual, upright, and magnified. Okay, so we just did our convex lens. Let's take a look at our concave lens. All right, now knowing that this concave lens is diverging, can you guys make any predictions about the images based on previous discussion? I'll let you guys make a prediction. What do you think we're going to see for images from a diverging lens? It's going to be virtual and it's going to be minimized. Remember, for our diverging mirrors, we always saw images that were minimized. So let's double check. All right, so we have an object. In this case, it could be anywhere. We're going to go through the lens and parallel and to the focal point. And then we are going to go straight through the middle of the lens. And we're going to see that those guys are not going to converge because this is a diverging lens. So we see this image that is upright, virtual, and minimized. So we've seen all the scenarios. We'll take note of that one real quick, and then we'll talk about our equation and how we would look at the signs. So for a concave lens that is diverging, there is only one situation, okay? We are always going to see image that is upright, virtual, and minimized. Okay. I'll give you guys that notepad to make sure you can see everything here in just a second. We just got one more thing to add. So back to our equation, 1 over F equals 1 over O plus 1 over I. Now for F, it's going to be the same. Positive F is going to be converging. Negative F is going to be diverging. So that just defines if your focal length is going to be considered positive or negative. For object, it's going to be same deal. It is almost always going to be positive. It basically means that your object is on the same side as light going in. So in this case, we're saying light is going this way. So that would be a positive object distance. Okay, for image distance, we will say it is positive if the image is on the other side. Because remember, we're saying positive is where we expect light to go. For a lens, we expect light to go through the lens. So positive image distance is going to be image on the other side. Okay, and then a negative image distance, which we would see here for our diverging lens, negative will be image on the same side. So that defines the sign convention for that equation. That's the last thing I wanted to make note of in our little notepad. And I'm going to just literally copy this thing and modify it for our lenses. Okay, we are done with our notepad, so I'm going to make this thing super huge. That way we can make sure that you guys can try and get it all. All right, if you want to take a screenshot, you can go ahead and do that now. I'll remove some of the extra spacing just so that you can even see more of it. Give a couple more seconds. Oh, and awesome. Allie has said that she will email you guys this afterwards. So if you couldn't grab a screenshot, then you'll still have an opportunity to get this a little bit later. Allie's the best. Okay, so you'll be able to grab this a little later this evening. All right, how do you guys feel about trying a couple questions? I feel like you guys have been killing this, and a couple questions would probably be good for you. So I think we're ready to do it. Right here. I'm going to give you guys some time to try this, okay? I'm going to give you guys some time. So let's give you a minute on the clock to try and solve this. And okay, let's see if you guys saw this right. So we're going to talk about it together, and you guys can kind of compare your work. Okay, hopefully you guys can hear me now. I was a little right there for a second. Okay, so let's see if you guys did this the right way. All right, so let's read and see what we could determine from the questions now. An object stands 12 centimeters from a diverging lens. If the image is formed 2 centimeters from the lens on the same side as the object, what is the focal length of the lens? Now, I want you guys to tell me if we get any clues in the question stem that would help narrow this down immediately. Is there anything we could see that would really, really help with this right away? I'll point you guys to the fact that 2 answer choices have negative focal lengths and 2 have positive. Yeah, absolutely. It says that this is a diverging lens, which means the focal length has to be negative. So guess what? We can narrow it down to 50-50 immediately. How awesome is that? So C and D are out. Okay, not bad. So if you ran out of time, you would literally be able to make a guess between A and B, which is a lot better of a guess than all of them. Now, to finish this thing up, we would need to solve. Okay, so we're going to use the equation 1 over F equals 1 over I plus 1 over O. Now, sometimes it's helpful to kind of like have a little picture to help you figure out what the heck's going on here. Okay, so an object stands 12 centimeters. Okay, so that distance would be 12 centimeters. And then it says if the image is formed 2 centimeters from the lens on the same side. Okay, so that would be here. And I'm not worrying about is it upright or virtual because it doesn't matter, it's one distance. So this is 2 centimeters. Okay, so we need to start plugging our distances in. All right, why did we say that image distance is -2? Why did we say that? Well, remember, we said that image is going to be negative if it's the same side, because that's not where we expect light to go. Image was negative, it's the same side, and positive if it was on the other side. So that is one of the big things you would have to have in order to make sure you're doing this right. Okay, so from there, we're just going to have to solve this thing. It's just a little bit of math. All right, so we need to get common denominator. Pretty normal. Okay, 1 over 12 minus 6 over 12 is going to be negative 5 over 12. Now from here, remember that to solve for f, well, right now we're 1 over f, so we just need to take the reciprocal, so it's going to be negative 12 over 5. I mean, at this point, you can tell that it's larger than 2, and that's all you need to do in order to get this correct. Our correct answer is answer choice A. Now, I'm pretty happy, even if you didn't get this completely right in the end, all of you guys were telling me that you knew that we should eliminate C and D because it said diverging lens, and that right there, my friends, is a win. So awesome job, your little pink star there on screen. Great work. I'm super excited about that. Okay, let's go ahead and try one more question before I hand it back over to Allie. So we're going to take a look at question 3. Now this one comes back to that idea of what happens with refraction in different media. So we'll give you 1 minute to take a look at this one. Go ahead. Okay, come on back. Our last question together. Okay, so we see a light ray of wavelength 600 nanometers enters a piece of glass with index of refraction 1.5. Which of the following best describes the path of the emerging ray? Okay, so we're comparing air and glass, and then we're comparing glass and air. Okay, so how should we consider this relationship and the angle between them? What's kind of our first thought? How would we think about solving this? What do we need to consider? One thing I'll point out is it doesn't say what it's traveling from, but you're basically assuming it's going from air because that's what the answer choices say, even though the question stem doesn't say it. Now, the index of refraction for air is 1. So you're comparing N of air, which is 1, to N of glass, which it's saying is 1.5. So we're going to use Snell's law to do this. Like you guys said, we have to figure out if it's bending away or towards. Okay? So N1 sine theta 1 equals N2 sine theta 2. And we're going to say that N of glass is higher. Based on that, we can decide what's going to be true of the angles. And that is for air, it's going to bend away. Okay? So it's going to be a larger. So we are going to see for air, it's larger. For glass, it is smaller. So we're going to expect the diagram to look like that. And our correct answer has got to be answer choice A. Another little trick you could kind of use here is that you would expect what it did on the first interface to be the opposite of what it does on the second. So that's kind of one quick way you can eliminate 2 answer choices, right? For answer choice C, it gets closer, and then it gets closer again. Well, we wouldn't expect that because you know it's going to a higher index of refraction, then it should do the opposite when it goes back. So that means B should be out as well because that one goes out and then out again. So 2 of them you could have eliminated with logic, and the other 2, if you had to, you could guess. So I'm a big fan of eliminate when possible to at least help you out. All right, guys, you did such an awesome job throughout this lesson. But guess what? The fun's not over, because I get to now hand things back over to Allie, and she's going to have some fun coaching you guys to more MCAT success. So thanks so much for letting me spend the last hour or so with you guys. Bye.
Hi again. Wasn't she so great? Can y'all just tell her how great she is? Because I don't think that she can hear it enough. Like, I think she is amazing. Did you know? Who knew you could have so much fun with light and optics? Who knew? I didn't know, not until I met Kristen Russell. So, no math MCAT, Ashwarya. That's absolutely right. And I'm so glad that y'all enjoyed that. I knew you would. Didn't I tell you ahead of time? I knew you were going to love it. And we're going to talk about some other stuff now. We're going to move into coaching, which I'm really excited about. And today's topic is, of course, how to retain the most information. Can you guys think about any real life situation that you're going through, like right now or sometime soon, like maybe in the spring, where you might need to recall some retained information? Can y'all, I mean, is there like, would you have any purpose for this lesson? Because if you don't, we don't have to have it, like, you know. And also, I did tell you too that this is a subject actually tested on the MCAT. So we're putting a little MCAT in our MCAT here with coaching, which I'm like super excited about. Your test, oh my goodness, your test. Yes, of course. The MCAT on your finals, on a lot of stuff actually. But I'm going to, of course, frame it in terms of the MCAT, because my one and only job is to ensure that you guys do really well on that particular test. And so I'm going to frame everything around the MCAT for today's coaching session, which again, I'm super, super excited about. So can anybody tell me what part of the MCAT your learning and memory is going to be tested in? Does anybody know what section of the MCAT that's going to fall under? Because if you, I mean, even if you're not for sure, I think you could probably guess. I think you could probably guess that that is going to be one of our testable topics underneath the Psych Soc heading. And you know what? I love Psych Soc because I myself am a social science major. And I feel like sometimes people are like, are you really a scientist? I'm like, yes, I am. Yes, I am. I have a bachelor's in science. I sure do. Is anybody else a social science major? Is anybody willing to admit? Sometimes I feel like I've gotten laughed at in the past for that. But listen, if you're here with me, you say it loud and proud, because we're same playing field, totally same playing field. So we're going to talk about learning and memory. We're going to talk specifically about how you can retain information, how you can store it. There you go. There you go. My social science majors representing. Hi. Hi. That's for you. I'm very excited to see you. But so this is what we're going to talk about. We're going to talk about storage and the retention of information. And we need to talk about that because you have your MCAT coming up and you're going to need to be able to pull up material that you have retained. And, you know, the definition really of retention in its easiest form is just having information that's available when we want it back, right? So not information that's going to run away from us, but information that's going to stay right there in our heads so that we can use it whenever we need to or whenever we want to. The primary factors, of course, are capacity and duration. And we're going to talk about those two factors and kind of how they play in to your retention. And we're going to do it right now. I want to talk about sensory information. Sensory information. Do you guys know what that means? Is there anything sensory going on around you right now that you could point to? I feel like the word sensory kind of gives it away, right? It's your senses. It's your senses, right? It's what's right in front of you. What are you seeing? What are you hearing? What are you smelling? What are you touching? But these are things that we really interact with these things very passively. Very passively. And I'm going to give you an example, and then I'm going to put an example on the screen. It's a different example, but I want to give you an example right now. Did any of y'all do the poll that I had up earlier? I had a poll up. What is your favorite thing that you've learned so far at Kaplan? Did you guys answer that? I know that you did because I saw the word cloud. It makes like a word cloud, and I saw that patterns was like the largest word, and I was like, oh, be still my teacher heart. But for those of you who did that poll, Can you tell me the extra letters that were on that poll? Did you notice that there were some letters on either side of it? Because I did that on purpose. I do lots of things on purpose. And I know that a lot of you answered that poll. In fact, I think I can tell you how many. Let me look. How many of us answered it? Yeah, about 50 of us answered it. So we read it, we looked at it, and it had a bunch of letters on it. Does anybody know? Can you tell me the letters that were on it? Because, I mean, it was there. You saw it, right? This is sensory information. It's stuff that you don't there was an S in it, Eric. There was. Well, Caitlin, sure. And that's another part of sensory information, too, is that your mind, because you're not actively interacting, your mind is always saying, do I need this? Will I need this? Is this important? So if you say, oh, it's a typo, your mind's not going to pay any attention to it. Or if you think it's just a design, just something you're passing, your brain's not going to store that. So when we look at sensory information, the things that you're passively interacting with around you that you just kind of notice with your senses, those things are very rapidly lost. In fact, sometimes they're lost. You don't even get under a second. They might be lost immediately because your mind does not judge them to be interested or interesting or important to you. And so here we might talk about the ability to recall a few letters in a group. Like you might, like one of you, like Eric, notice a couple of the letters that were there, and so he kind of can remember that. But most of us can't remember any of the letters there, and many of us judged it to be a typo or just something extra, and we just immediately threw it away and paid no attention to it. Does anybody know what you would have to do in order to move that to short-term memory? Like, why would your mind then hold it just a little bit longer? What would you need to assign to it? A purpose, right? If you give it a purpose or a reason to be interested, or you attach it to something, then you can hold on to it like a little bit longer, right? So if I told you those letters right now and I said, hey, I'm about to ask you in a second what I just said, and I said that the letters were HIRGFSQLTZ, then you might be able to hold on to more of those letters for a little bit longer because I said that I might test you on it. Well, you're just going to write it down, Carol. But the letters were, in fact, HIRGFSQLT and Z, and they were not a typo. It was me putting a little of teaching in your teaching. So I hope that you enjoyed that. But once you start adding a purpose to something that you're trying to learn, then you can move it at least into kind of short-term memory. But again, you still have a very limited capacity there. And a lot of times the stuff that you're going to remember is going to be less than a minute. Isn't that interesting? You would think that it would be, or less, yeah, you would think that it would be a little bit longer, but it's really not. Does anybody remember phone numbers? Like actually a time when you had to know and memorize phone numbers? I don't know if you do. I'm like, maybe I'm showing my age right now, and we all have smartphones now, and I feel like nobody knows any phone numbers. But back in the day, we used to have to memorize all of our phone numbers. And in fact, somebody very smart discovered that kind of where we're at with our short-term memory, that we're going to be able to hold about 7 digits. About 7 digits we can kind of hold on to and retain. And so that's actually why phone numbers used to be 7 digits long. Isn't that interesting? They made it 7 digits long and didn't go over that because they knew that it was highly unlikely that would be able to remember more than 7 digits. So that was a purposeful choice on their part, which I think is really cool. And when you move something to short-term memory, because you've assigned some amount of importance, but not a huge amount of importance, you can then make your duration just a little bit longer than your sensory, the things that you're just interacting with. But let's talk about when you're working on a passage for the MCAT. Let's make this real, right? When you're working a passage on the MCAT, a lot of times we want to answer by memory. Anybody willing to admit you're trying to answer by memory on those passages? Don't lie. Don't lie. I know we do. We always want to try and get through it quickly. We're very fond of our own comprehension skills, but this is why you should always take at least a little bit of notes while you're going through your passage. You want to, because the scratch work serves as short-term memory. So now your details are being stored because you've kind of marked that they're important and you've done something to kind of concrete that in your mind that this is something I want to know because of the physical act of writing it. And so one of the things that you can do to enhance your short-term memory and to enhance your MCAT score at the same time is to take those notes as you go through your passage. They don't have to be super detailed, but they do have to be just kind of mile markers and an indication to your brain that this is something that you do care about, at least for the short term, and that you would want to have it, you know, here in like a minute or so when you answer your questions. And the really neat thing about that too is once you do your scratch work, which really does serve as your short-term memory, your mind kind of clears space to do other things. Your mind is like, okay, I don't have to remember everything in that passage. I made some notes about what I'll need. I can kind of remember those, and they're here if I need them. And so now I'm clear to think about other things, which is great. What a lot of students tend to do is you start trying to carry a lot at the same time. Like you're like trying to memorize everything from the passage and remember all of your science facts, and you're just putting your brain through like everything. But one way that you can kind of alleviate that, at least in your passage-based questions, is to make those brief notes as you're going through. And so that's something that I want you to start. Employing right away. So your short-term memory is going to be like your ability to maybe repeat a phone number or a grocery list. What would you have to do in order to remember what to pick up at the grocery store? What would you do? Like if you didn't write it down, I mean, how are you going to help yourself to remember? This is something I have to do all the time. I have to do it all the time. And in fact, I do it just out loud, which helps me because I told you the other day that I'm an oral learner. I got to hear things. But when you go to the grocery store, you're going to be repeating okay, I need cat food, I need orange juice, and I need milk. Cat food, orange juice, milk. Cat food, orange juice, milk. And you're telling yourself all the way to the store. And then I know this has happened to you when you get out of the grocery store, you're like, I forgot the cat food. Or like Target, because Target will really, every time I'm going to Target for one thing, I get everything but the one thing there too. So once you start kind of repeating things, then all of a sudden you can remember just a little bit better. And so this is something that you can do also to kind of increase your ability to retain. It's work with repetition, which we have talked about a lot this week. But let's talk about our working memory. Your working memory is actively working on multiple pieces of information. How long do you think your working memory could last? We've had maybe not even a second. We've had less than 1 minute. What do you think? Yeah, true. True, Adrian. Never go to the grocery store hungry. That's the worst plan. You always come back with crazy stuff. Crazy stuff. But how long? Working memory. Memory that can work on multiple pieces of information at the same time. How long do you think? We've kind of been moving up. But we're not moving up now. Guess what? It's the same. It's still under 1 minute. So you can think of this as like if you think about doing math in your head, when you start doing math, because I know we've said that we're doing the No Math MCAT. That's Ashwarya, teacher Ashwarya's hashtag for the week, the No Math MCAT. But when you try and do math in your head, you have to remember several different things. You got to remember the numbers that you started with, what mathematical operations you're doing, any intermediate numbers you get, and what to do with that information in order to get your final answer. And this is something that a lot of people try and do on the MCAT is you'll see something that maybe looks more simple to you, and you might try and do it in your head because you're like, oh, it's quicker, I'm going to get it. But a lot of times you're going to make mistakes, right? Because you're trying to hold on to so many different things at the same time. And you can really fall prey to some simple errors that you wouldn't if you just wrote it down. Because again, you have less than a minute of this working memory. So you have to make sure that one, you do really good work with it. And two, I would advise always on your MCAT to even just double check yourself and just write it out. Because when you do that math in your head, you are very subject to making mistakes. Because you're trying to keep so many things in there at the same time. But it is, of course, our goal to get our long-term memory activated because it has the highest capacity and it has the highest duration. Let's check this out. Look at your capacity. Limitless storage capacity. Limitless. How crazy is that? How crazy is that? Maybe you will be the scientist to discover, but as of yet, nobody knows the true capacity of the human brain. And so apparently, at least at this point, it could be limitless. It certainly can be for a long time. And we talked earlier about assigning meaning to something. So the more meaning and importance that you assign to something, the more likely you are to retain it. This is particularly important on your MCAT, because on your MCAT, you have to have stuff in your long-term memory. It can't be something that you cram the day before. There's too much information. It can't even be something you cram the month before. And you need to have it, and you need to be able to retain it and work with it in an instant. And you're not even sure whatever question is going to come up. So there's a lot of things that you need to make sure you have retained. And you have to make sure that they're retained for long periods of time. And the way that you're going to do that is by assigning particular meaning to it, making it very important to yourself, not just because we care about our MCAT score, but because we have actively given our brain signals that say, hey, yeah, I want this. I want it for a long time, and I'm really hoping not to forget it. And the way that you can do that is by studying in different formats. So if you're like reading your review books, we talked a lot this week about everybody having the 7 series review books, which is awesome. That's awesome. But it's only one way, right? It's not going to be good enough to move into your long-term memory because you're only learning it once. If you read a chapter, you've learned it once, right? So maybe you can help to move it into your long-term by reading it a second time, reading it a third time. But this is a very inefficient way, and it takes a long time. And so what you want to do instead is mix up your study methods. This indicates to your brain that something is really important to you because you're reading about it. You're going to class and talking about it. You're doing practice questions on it. You're watching a video. And all of a sudden, you have a very efficient way to move things into this long-term memory, which essentially could be limitless. And you could have memories up to a lifetime. And of course, how long you have it memorized really depends on how much importance you put on it. So like you might think about when you cram for a test. Has anybody ever crammed for a test and like you actually did pretty well on that test and like a week later you don't remember anything? I feel like I was the queen of this because I would like cram and then a week later nothing. But I got through the test all right. And that's because I did just enough to hold it for just as long as I wanted to, according to the importance that I put on it. And I told myself, this is important for this one day. So I'll take a couple of weeks, I'll drill it in there, and my brain's like, oh, this is super important, but only so important. We need to hold stuff a lot longer for the MCAT. And the way that you're going to do that most efficiently is by using several indicators, several methods of study in order to say to your brain, hey, I'm super interested in this. I want to have it for a long time, and doing that in an efficient way. Because if you only just read that chapter, again, it's not going to be stuck in there for life. Oh, good deal. Good luck to you. Good luck to you on that Kim exam tomorrow. But yeah, absolutely. We need to move everything for MCAT into long-term memory. And the way that you're going to do that most efficiently is by utilizing as many different forms of learning the material and as often as you can. You want to make sure that you're constantly using it and that you're using it in different ways in order to become most efficient. So again, your review books are great. Coming to class like you are right now and talking about it is great. Doing practice items on that topic to kind of pull all of what you've learned together, watching a video, taking a quiz, all of these things together become an efficient way to retain. So what you have to do is really think about in your study, am I signaling that I want to hold this for as long as possible? Am I doing as much as I can to retain in the most efficient way for the longest amount of time? And the way that you're going to do that is with several different types of study on the same topic in succession. So if you do that, you're going to be most successful. And that's what I have for you in coaching today, how we're going to be super successful in retaining our information. We want to get it into long term, and how we can do that, we're going to ascribe importance to it. We're going to do that by repeatedly studying it. We're going to study in multiple ways, in multiple formats, with multiple resources, and in order to retain the most efficient way. And then we will hopefully have moved stuff into our long-term memory, like the slide says, memorizing those blood type antigens, because you don't want to have to really think through that. You don't want to struggle through it or have gaps in your memory. These are things that you want to know like that on test day. And the way that you're going to do that is through your repetition and through your use of multiple resources to study over and over and over again, right? Don't just study in one way because it's likely not going to be enough. If you read a chapter one time, even if you understood it perfectly when you read it and you're like, oh, that totally makes sense. If you don't do something else and you don't follow that up, that's not going to long-term memory. That's not going to happen. It's like when I used to sit in math class and I'd be like, oh, I totally get it. and then I wouldn't do any homework and I wouldn't read anything. It'd be like 2 weeks later and I'm trying then to do the homework and I'm like, man, I feel like I totally got this before and now I just can't, I barely can remember, like, she said something about something about something. That's how you're going to be with MCAT material. If all you do is read the chapter and you totally get it and you're like, oh, check, it's checked off my list, goodbye. Guess what? When you finally return to it, it's going to be like, oh, what did that chapter say? I totally got it. I totally got it when I read it, but now where did it go? That's why. Now you know why. And so I hope that you did enjoy this coaching session. I really think that these points can really help you in your MCAT prep and also on your actual MCAT because this is testable MCAT material. So I'm glad that we were able to do that. You know I love to put MCAT in our MCAT, so we'll just keep doing that throughout the week. And tomorrow's lesson is, of course, acids and bases. Is anybody excited about that? Acids and bases? I know you were because you said today was acids and bases last time. You're like, oh, acids and bases. I was like, it's not. It's light objects, which is going to be just as awesome. But I know that a lot of you were looking forward to this. So tomorrow we have our acids and bases. I'm going to send out homework like per always. I think I have the poll is still open. Make sure to put your email in that poll if you want to get it. And I did hear from some students that were saying that they weren't getting the emails, but they put their email in. Sometimes it's just make sure that you didn't misspell your email or make a typo or anything. And then you can always just email me directly and let me know, and I'll send stuff to you. And another thing that happens sometimes too is that I will get filtered out of your email because I have a Kaplan account and they think that I'm just like some corporate spam bot, but I am not. I'm your coach and I want to talk to you. I want to teach you things. So, but if you're just not getting something from me, just write me and I'll send it. But Caitlin, listen, if acids and bases are your weak spot, then you should definitely come because we can help you to clear all that up. So I'm really excited. Adrian, you're funny. Yeah, I dropped Mike on that one. But do remember that when we're thinking about all of the resources that we should be using, and you're thinking about where do I get all these resources and how am I going to find them and how am I going to put them together and which ones should I use and how will I know? Just come to Kaplan because we did all that for you and you don't have to think about it. Listen, we just talked about the need to free up your brain of stuff that you only need to remember for less than a minute, and how to make room for the things that we need to hold on for potentially a lifetime or at least for the next 9 months, right? So clear your mind, take some weight off of it by knowing that if you just come to Kaplan, all of that stuff is taken care of for you. And there was another thing that I wanted to talk about. The link is up above. Can we just talk for a minute about the free trial of Kaplan MCAT? Can we just talk about that? I didn't get to talk about it a lot yesterday, and we put the link, and I was just kind of like, it was kind of a throwaway. I was like, oh yeah, free trial. And some of y'all emailed me, and I felt bad because I didn't really get into discussing it as much as I wanted to or should have. So I definitely want to talk about that today before I run out of time. So that link is awesome. You can sign up there. You will get a whole week of a free trial of Kaplan. It's different than this. So here we're kind of highlighting our MCAT channel, and we're showing you some of our lessons, some of our teaching styles. Inside of the MCAT free trial, you're going to actually get to touch and play with Kaplan MCAT materials and product and how it works inside of our kind of environment. And you get this awesome taste of Kaplan MCAT all in one place. And it's totally free. So there's no reason to not do it. So I hope that you will sign up for that so that you can get a week of use of Kaplan stuff. I mean, it really doesn't get better than that, I don't think. And as much as I love the free week of MCAT channel that we're doing, I think that the free trial is going to be even better because you get to have more stuff to practice in more ways. We got videos in there. We got practice items. We got lessons. And then all of a sudden, you're memorizing stuff because you're studying it in different ways over and over time. So make sure that you sign up for that if you have not yet. It's going to be awesome. Yeah, that's right, Ashwarya. QBank is Bay. That's my Bay too. And my tutoring students, I have them in their QBank all of the time. That's probably when they're in there the most. But that's what I have for you. Can I answer any questions? I know we only have 5 minutes left for Q&A, but I want to get to them. Send your questions. Send them now so I can answer them. I see, Adrian. I'm glad that you're thinking about the MCAT free trial. It's going to be awesome. And when you sign up for it, it starts immediately. You start right then. So whenever you want. Any day can be day one. Isn't that like one of the first things that I taught y'all? Any day can be day one with Kaplan, with MCAT, with reaching your goals. Your future is so bright. All of that. Any day is day one. And that goes for the MCAT free 7-day trial as well. Emilio, can it be accessed from a mobile phone? Oh my gosh, I am so proud to admit that Kaplan has recently, do you have Apple? We've recently made everything iOS compatible. And so if you do have Apple products or Apple phone, you can actually access all of Kaplan resources. If you're enrolled in the course, you can access all of our resources via app. So everything is apped. Like our QBank is apped, our lessons are apps, everything. I don't know specifically about the free MCAT trial. I'm not sure. I'm not sure, but you can find out because it's totally free. And if you sign up for it, then there you are, and then there you'll know. But I do know that our course is, so maybe. A QBank, Kimber, our QBank is the way that we can target certain questions. So we just said that in order to get something into long-term memory, we have to repeat it over and over. We have to assign a purpose to it, an importance to it. We have to study it in different ways. So one of the ways that we do that is with our QBank. And there, our students can filter down to exactly what they want to study and what type of question. They can have it on tutor mode, where an electronic tutor kind of walks them through it with explanations. Or they can have it on timed mode, so it can be realistic, like the MCAT. And it's just the way that we can target certain question types. Because if you learn something like, oh, this is how you answer this particular question, and then you don't see another one of those for a long time, guess what? It's not going to long-term memory, as we just discussed. So what we'll have our students do is, oh, you just went to that MCAT channel lesson. Why don't you go to your QBank now and practice some of those questions of that type so that you can start moving it into long-term memory. So it's just basically the way that we filter questions and that we're able to target certain things that we want to work on. And I did want to mention too, a lot of y'all emailed me about Kaplan, signing up for Kaplan, which I know, listen, Kaplan's awesome. I totally agree. You're making great decisions. You obviously have great taste. And I was able to talk to a lot of you, but I did want to let you know that I did not tell you this before because I was remiss in my duties, but I want you to know that all of you as members of this free prep week or free week of channel sessions are all entitled to a huge discount. It's $250 off of our course. Which is the biggest sale that we're going to have. I know if you go to our website right now, I think it's like $150 for everybody else, but not for you because you came here. And so no one's going to have that discount but you. The code is MCAT250. Can we pin that up on the notes? Can we just pin that code up there? So that if you do end up enrolling, I want you to just know that that's out there. They probably emailed you already, but you know how I like to put a lot of words on top of stuff. What else have we got? What else have we got? Send those questions. I have 1 minute left. And y'all, I finished on time. Again, this is like a record for me. 2 days in a row, I finished on time. This is actually huge. Oh, and I'm so glad that you enjoyed that session. I did see your note on how helpful you found this to be with the memory and stuff. I was really excited about this one, Robbie. I was super excited about this one myself because it's a way to put a little MCAT in our MCAT because this is an MCAT testable topic. So I'm really excited about that. But make sure and just copy everything that's above because you should be emailing me. Your email's in my poll, so I'm going to send out. And I'm going to add, do not let me forget, I am going to send out Teacher Kristen's. This is me repeating this out loud so that I can retain it just a little bit longer. Science in your MCAT. It's like Inception level MCAT. I am going to send the notes that she had in that pod along with my recap email and along with the homework, the primer for tomorrow's acids and bases lesson. Yes, Adrian, of course. I'm going to send that out too, along with these notes and whatever helpful thing I also have. You never know what you will get from Teacher Allie. But I do see that the questions are slowing down. So I just want to say again, you guys know I love to always end on the same note. I want to thank you so much for coming here, for choosing Kaplan, for allowing us to be a part of this journey in your life. I mean, it's a huge deal and it's a huge honor to be chosen for that. And We're just so happy to be a part of your success team for the MCAT coming up. And I can't wait to see you tomorrow for our acids and bases lesson. And look out for my email. Make sure that your email is in the poll. We'll leave it up for just a little while longer if you haven't put it there. And if you do put it there, you'll get Teacher Kristen's notes from her notepad, and you'll get your homework primer for next lesson, and maybe something else. You never know what I'll put in there. But I look forward to seeing you soon. And soon as tomorrow, be there.